Hello everyone, welcome to Sri Vlogs Fun and Edutainment channel. We provide you education with entertainment. Right, students, in today's class we discuss two very important frequently asked questions in your previous examinations. Okay, shall we start? Let us dive into our topic. Right, students, so this is the question. If W equal to log Z, find dW by dZ if it is analytic and determine where W is non-analytic. Okay, so see here the given function is W equal to log Z. So first we start from the given function. So given that W, let us take it as f of z, that is equal to log z. Right, what we did in the previous problems, right, exactly. So in the place of z we substituted x plus iy because we clearly know z is equal to x plus iy in Cartesian coordinates. Clear? Okay, here also if we substitute in the place of z x plus iy, what we get, just observe. Right here log x plus iy. So it cannot be in the form, it is not in the form u plus iv. Okay, if we write directly in the place of z x plus iy here, what happens? Log x plus iy. That means it is of the form log a plus b. Do we have any formula for log a plus b? Right, we don't have any formula for log a plus b. Log a plus b remains log a plus b. So we cannot apply any formula for log a plus b. Then what we do here? We cannot do anything if we write directly in the place of z is equal to x plus iy. So what we need to do now? It is the first question. Right, exactly. So here we know in our previous intermediate level, z can be written in Cartesian form x plus iy, as well as z can be written in polar form. What we can write z in polar form? Yes, polar form means the coordinates are in the form r comma theta. In polar form the coordinates are r comma theta. So our z can be written in polar form r into e power I theta, which we learned in our intermediate level. Okay, if you come from diploma, we learned it in our diploma level also in complex numbers. Okay, so in Cartesian form z is equal to x plus iy. In polar form we can write z as r into e power I theta. Okay, remember that, r into e power I theta. So from that we get log z as 1 by 2 log x square plus y square plus I into tan inverse of y by x. Okay, sir, how do we get this? If z is equal to r into e power theta, then how do we get 1 by 2 into log x square plus y square plus I into tan inverse of y by x? If you want to know, I will explain. No need of writing all that in your examination. Just you need to remember log z can be expressed as 1 by 2 into log of x square plus y square plus I into tan inverse of y by x. Okay, but I will explain it in better manner. How do we get this expression? So here we don't substitute z in Cartesian form, we have to substitute z in polar form. Right, so what is our polar form here? R into e power I theta. So what is r? Okay, in polar form we know that in complex numbers So r is equal to root of x square plus y square. These are the relation between polar coordinates and Cartesian coordinates. And theta is nothing but the amplitude, principal amplitude tan inverse of y by x. So z is equal to x plus iy can be converted to the polar form r into cos theta plus I sin theta. As we know, cos theta plus I sin theta. Cos theta means x by r. Sin theta means y by r always. Cos theta means if it is 90 degrees, so this is x, this is y, and this is our r. Cos theta is equal to adjacent side by hypotenuse. Okay, in trigonometry clearly we know it. So sin theta is equal to opposite side by hypotenuse. So cos theta is equal to always x by r. Sin theta is equal to always y by r. Okay. Now x is equal to r cos theta, y is equal to r sin theta. We can write it as, so r into cos theta means x plus iy. Okay. Or here r get cancelled. We get x plus iy. Okay. So r into cos theta plus I sin theta, we can write x plus iy, we can write in polar form r into cos theta plus I sin theta. So clearly r into cos theta plus I sin theta can be written in exponential form as e power I theta. Okay, clear? So here also, here we are substituting in the place of z, r into e power I theta. Now it can be written like it is of the form log AB. So we know the formula for log AB. We don't have the formula for log A plus B or log M plus N, but we have the formula for log M into N or log A into B. You can take any symbols. Log M into N is equal to log M plus log M. Log M plus log N. Okay. So by using that formula, here log m into n is equal to log m plus log m. So using that formula, here we get in the place of m r is there, in the place of n e power I theta is there. So log r plus log e power I theta. Okay. Now log r, we know that r is in Cartesian coordinates root of x square plus y square. So root of x square plus y square plus log e power I theta. So log m power n, we can use the formula. Log m power n is n log m. That means we can take this I theta to the multiple of logarithm I theta into log e. So if there is no base for logarithmic functions, we have to understood that the base should be e. So log e base e, logarithm to the same base is equal to 1, we know clearly. So log root x square plus y square plus I into theta into log e base e. Now here root can be written as x square plus y square whole to the power of 1 by 2 into I into theta. What is theta? Theta is the principal amplitude in polar coordinates. This is the relation between polar and Cartesian. So theta is nothing but tan inverse of y by x into 1. Log e base is nothing but 1. So this is also in the form of log m to the power of n. So log m to the power of n is always 1 by 2. 1 by 2 can be taken to the multiple of logarithm. Now 1 by 2 into log x square plus y square plus I into tan inverse of y by x. Okay. So in this way we get log z is equal to, okay, what I told just now, 1 by 2 into log x square plus y square plus I into tan inverse of y by x. So you need to remember directly this. No need of doing all these things because already we learnt in our previous classes all this stuff, so that it is important or you remember this log z as 1 by 2 into log x square plus y square plus I into tan inverse of y by x. So how do we get this? For that purpose only I explained this. Okay. So the step number 1 is log z is equal to 1 by 2 into log x square plus y square plus I into tan inverse of y by x. Now clearly it is of the form u plus iv. Okay. So u is 1 by 2 into log x square plus y square and v is tan inverse of y by x. Now our next step is to do the partial derivatives for the functions u and v and check the Cauchy-Riemann conditions. Clear? Comparing to u plus iv form, f of z is equal to u plus iv form, we get u is equal to 1 by 2 log x square plus y square. 1 by 2 log x square plus y square, and v equal to tan inverse of y by x. Now we need to find dou u by dou x, dou u by dou y, and dou v by dou x, dou v by dou y for these functions. Now coming to the u, this is our step 2. Remember that. Now u is equal to 1 by 2 log x square plus y square. I am finding dou u by dou x, dou u by dou x. That is dou by dou x of 1 by 2 into log x square plus y square. Now please be concentrated here. Here dou by dou x of 1 by 2. Okay, clearly 1 by 2 is a constant, fixed constant, so we can take it out 1 by 2. No problem for 1 by 2. And here it is log. In the logarithm we have x square plus y square. That means it is clearly in derivatives, it is clearly composite function. Composite function. When doing the differentiation for composite functions, just close the internal function. What is appearing to you? Log function. What is the derivative of log function? Yes, 1 by. The derivative of log function is 1 by. And just open the internal function. What is appearing? X square plus y square. That means log function differentiation is 1 by this internal function x square plus y square. Okay, clear? But the derivative can't stop there. We have to write, it is called chain rule. We have to write into d by dx of x square plus y square. You have to differentiate for the internal function also. If it is x, if it is not x square plus y square, if it is only x, then our answer is 1 by x. But here it is not x. Students, remember that it is not x. It is x square plus y square. That means 1 by x square plus y square, because the differentiation of log function is 1 by. So 1 by x square plus y square. We can't stop here. We move to the next, that is called chain rule. Into dou by dou x, I have to derive the internal function. That means this x square plus y square. Okay, clear? Right. So because of the composite function, we have to do like this. This is the differentiation rule for composite function. It is called chain rule. Now this is 1 by 2 of x square plus y square into dou by dou x of x square. Okay, x matched. So what is the derivative of x square? Right, exactly 2x plus dou by dou x of y square. What is the derivative of y square? Is it match? Here it is x and here it is y. That means variables not matched. If the variables not matched means it is treated as constant. So y square is constant. Okay, clearly y square is constant. Okay, y is not a function in terms of x here. Y is independent variable. Okay, y is independent variable. So with respect to x, y is treated as constant, so that the differentiation of y square is 0. Okay, now calculating, here it is 2, here it is also 2, so 2 got cancelled. Now what is remaining? X remaining in the numerator, x by what is remaining in the denominator? X square plus y square. Good. So this is our ux. It can be denoted in short form ux, as simple as that. Okay, clear? Right. Now we move to find dou u by dou y. With respect to y, we do the differentiation now. So it is also same process. Dou by dou y of, because 1 by 2 is a fixed constant, we are taken out 1 by 2. 1 by 2 of dou by dou y of log x square plus y square. So we follow the similar process as like above. 1 by 2 into log function differentiation. Just now we discussed x square plus y square into dou by dou y of the internal function, that is x square plus y square. Now observe here, it is y, we are doing differentiation with respect to y, but here it is x, so x totally treated as constant, so 0. So 1 by 2 into x square plus y square. X square differentiation with respect to y is 0. Y square differentiation with respect to y is 2y. So these 2 and these 2 get cancelled. We get y by x square plus y square. Clear? Okay. So this is our uy in short. Uy. Now coming to the v. Partial derivative. Right here, v equal to tan inverse of y by x. So you need to find dou v by dou x in similar manner. Dou by dou x of tan inverse of y by x. Right? What is the differentiation of tan inverse? Right. So exactly, tan inverse differentiation is 1 by 1 plus x square. You need to know all these formulae. So we are getting all these formulae in our problems, so that I didn't reveal the formulae in the previous classes. So that we are getting a formulae according to problem. We will discuss the formulae. That's why I didn't discuss in the videos. Okay, right? Tan inverse. Tan inverse is 1 by 1 plus x square. Here tan inverse function differentiation is 1 by 1 plus x square. Here, so 1 by 1 plus x, in the place of x, what is there here? Y by x. So y by x whole square. Don't stop here. You need to derivate the y by x also, because it is the composite function. Okay, now 1 by 1 plus calculation part y square by x square into dou by dou x of y by x. Okay, so here y is constant, already we know. Take the y out and dou by dou x of 1 by x. Now 1 by 1 plus y square by x square, so simple calculation required here. So take this x square as LCM and move to the numerator. We get x square by x square plus y square into, already y is there, into y into 1 by x differentiation. Right, 1 by x differentiation is minus 1 by x square. Okay, you need to remember this direct formula, because it will come frequently in our problems. So 1 by x differentiation is minus 1 by x square. You can calculate by using x to the power of n formula. Take this x by denominator x to the numerator, you get x to the power of minus 1. So x to the power of minus 1, you apply the formula x to the power of n into x to the power of n minus 1. From that we get here minus 1 by x square, right? So in the numerator x square is there, in the denominator also x square is there. X square get cancelled. What is remaining? Minus y by x square plus y square. Clear? So in short, we denote it as Vx. And coming to the Vy. v by or dou v by dou x. Dou v by dou y. Right, dou v by dou y. So dou by dou y of tan inverse y by x. Here also the function is tan inverse. What is the differentiation for tan inverse function? 1 by 1 plus x square. It doesn't change. For log function, 1 by. For e power function, e power only. For x power function, n into x power only. Okay, like that you remember. So for sine function, cos. For cos function, minus sign. So you remember the formula by treating their functions. Sine, cos, tan. For tan function, sec square. So if the internal function is there, it is we have to convert it, consider it as composite function. Composite function. If it is composite function, then we again differentiate the internal function also. It is called the chain rule. Okay, you need to remember that. So here it is tan inverse. So tan inverse function differentiation is 1 by 1 plus x square. If it is sine inverse, 1 by root 1 minus x square. You need to remember all these formulae. Okay. Okay. So here tan inverse is there. So 1 by 1 plus x square. 1 by 1 plus x. In the place of x, y by x is there. So y by x whole square into dou by dou x of y by x. Now we need to calculate it. Some more calculation is needed here. X square by x square plus y square. Already we did in the previous one. What we get here? X square by x square plus y square. Similarly, we also get here x square by x square plus y square into dou by dou x of y by x. So here, sorry, not y, not x here. Here y. Dou by dou y of y by x. 1 by x is the constant and differentiation of y is nothing but 1. Now here x and this x get cancelled. What is remaining? 1x is remaining in the numerator. So x by x square plus y square. Clear? So it is our vy. Now we got ux, uy and vx, vy. Okay. Now the step number 3 is checking the Cauchy-Riemann conditions. Cauchy-Riemann conditions. What are Cauchy-Riemann conditions? Ux should be equal to vy. So what is our ux here? X by x square plus y square. So vy is also x by x square plus y square. So first condition satisfied. Now uy, what is uy? Y by x square plus y square. So uy should be equal to minus vy, minus vx, sorry, minus vx. So here vx is minus y by x square plus y square. So it is also equal. Clear? That means Cauchy-Riemann equations are satisfied. If Cauchy-Riemann equations is satisfied, this function is analytic. If this function is analytic, we can derivate this function directly. But if you observe the question, find dw by dz when the function is analytic. Also determine where the function is not analytic. What is this meaning? Where the function is not analytic. Not analytic means it should not be differentiable. Where this function is not differentiable, you have to identify. So if you observe all these partial derivatives contains the denominator. So ux have the denominator x square plus y square. Uy is also have the denominator x square plus y square. Vx is also have the denominator x square plus y square. Vy is also having the denominator x square plus y square. That means if we take the point z as origin is nothing but 0 plus I into 0. That means in the place of x 0, in the place of y also 0, okay, in the place of y also 0, then what happens to the denominator? Denominator is 0. So if the denominator is 0, the function is not defined. That means if z is equal to 0, the function is not defined. That means the function is not differentiable. That means the function is not analytic. So where the function is not analytic? Where this function not analytic? At the point z is equal to 0. Clear? So the differentiation of the function exists except z is equal to 0. except z is equal to 0. Clear? Verification of CR conditions. So clearly we have ux is equal to x by x square plus y square, x by x square plus y square, that is equal to vy, that is equal to vy, and uy is equal to y by x square plus y square, y by x square plus y square, and that is equal to minus vx. So CR conditions satisfied. CR conditions satisfied except z is equal to 0. Z is equal to 0. What happens if z is equal to 0? X square plus y square. X is equal to 0, y is equal to 0. That means the denominator is 0. The denominator 0 means partial derivatives not exist. That means since if z is equal to 0, ux, uy, vx, vy does not exist. That means fz is not analytic at z is equal to 0. Fz is not analytic at z is equal to 0. F of z is equal log z not analytic at z is equal to z0, that is equal to 0. So therefore dw by dz, the differentiation w is equal to log z. We can find dw by dz, that is d by dz of log z. So what is the differentiation of log z with respect to z? Log function differentiation is 1 by. Okay, already we know it. So 1 by z, since z not equal to, so dw by dz, that is equal to d by dz of log z, that is equal to 1 by z, only when z not equal to 0. If z is equal to 0, the derivative of log z is not defined. That means log function is not analytic at z is equal to 0, and the differentiation of log function log z is 1 by z. Clear? Right, we will discuss one more important question which is asked previously in your examinations, is prove that f of z equal to z power n is analytic, find its derivative. Right? So here the given function is f of z is equal to z power n. Now what is the first step? Right, in the place of z we have to keep x plus iy, right? So if we substitute in the place of z x plus iy, so the function changed to x plus iy whole to the power of n. Then how do we convert this x plus iy whole to the power of n to u plus iv form? So in this method, that means in Cartesian coordinate system, we cannot convert this function to u plus iv form. So that here it is required polar coordinates. So in this problem, so some particular problems we need to use only polar coordinates. That means we need to know the Cauchy-Riemann conditions in polar coordinates. So this is the specific problem. We need to apply polar coordinates only to prove analyticity of this function. Now already we discussed in the previous problem the relation between polar coordinates and the Cartesian coordinates for the complex variable. Okay. Now Already we know z is equal to x plus iy. It can be written in polar form r into e power I theta. Clear? So we are writing x plus iy as r into e power I theta. R into e power I theta whole power n. So it can be written as r power n into e power I theta whole power n can be written as e power I n theta. E power I into n theta. Already we know that e power I theta formula cos theta plus I sin theta. Clear? So what is in the place of theta here? Right, n theta. So according to that we can write e power I n theta as r power n into cos n theta plus I sin n theta. Okay. So if we multiply this to the internal functions, r power n into cos n theta plus I into r power n into sin n theta. That means we converted f of z into polar coordinates. That means f of z is equal to u of r comma theta. So u is a function in terms of r and theta, as well as v is a function in terms of r comma theta. Okay, so clearly u of r comma theta is equal to the real part r power n into cos n theta, and the imaginary part, that is v of r comma theta, is equal to r power n into sin n theta. Clear? Now we need to find partial derivatives of u with respect to r and with respect to theta. In the previous problems we find partial derivatives with respect to x, with respect to y, because they are in terms of Cartesian coordinates. But here in this problem the coordinates are polar coordinates. So we need to find the partial derivatives with respect to r and with respect to theta. You need to remember that. Okay? Clear? See here, u equal to r power n into cos n theta, and v is equal to r power n into sin n theta. Now you need to find dou u by dou r, dou u by dou theta, and dou v by dou r, dou v by dou theta. Right, now first we find dou u by dou r, that is dou by dou r of r power n into cos n theta. So what is the variable here? R. So here r is there, so r matched. So here it is theta. So with respect to r, theta considered as constant. So we need to take this cos n theta out and do the differentiation for r power n only. Dou by dou r of r power n. So it is like dou by dou x of x power n. What is the formula for dou by dou x of x power n? N into x power n minus 1. So clearly here also dou by dou r of r power n is nothing but n into r power n minus 1. Clear? So cos n theta into n into r power n minus 1. So we are writing in an order n into r power n minus 1 into cos n theta. So it is our u with respect to r, and we need to find with respect to theta also. So dou u by dou theta, we are finding dou u by dou theta. That means dou by dou theta of r power n into cos n theta. So here it is theta. So with respect to theta, r treated as constant. So you need to take out r power n and to differentiate cos n theta function only. So that is equal to r power n into dou by dou theta of cos n theta. Clear? Now dou by dou theta of cos, here function is cos. What is the derivative of cos function? Yes, minus sine. But here in the internal function it is not theta, it is n theta. So it is composite function. So we have to derivate again for n theta. What is the derivative for n theta? That means nx, d by dx of nx. N is a constant, x derivative is 1. That means n. So here also n theta derivative is n. With respect to theta, n theta derivative is n. Okay, clear? So that we get here r power n into cos function derivative is minus sine. So that minus n theta derivative, I am writing directly using the composite function derivative. So minus n into sine n theta. Minus n into sine n theta. So I am writing in an order minus n into r power n into sine n theta. Minus n into r power n into sine n theta. This is dou u by dou theta. In similar way, we find dou v by dou r. So dou v by dou r is equal to dou by dou r of, as like in the for r power n, as like u have to differentiate v also. Okay, dou v by dou r power n into sine n theta. So here with respect to r we are doing the differentiation. So sine n theta is constant. Taking out the sine n theta, dou by dou r of r power n. Same x power n formula. So n into x power n minus 1. So n into r power n minus 1. N into r power n minus 1. Into sine n theta is there. So sine n theta. This is our VR. So we have to find dou v by dou theta with respect to theta. So dou v by dou theta is equal to dou by dou theta of r power n into sine n theta. So here r power n is constant. So taking out the r power n and do the differentiation for sine n theta. Sine function derivative already we know cos n theta into n theta differentiation, because it is composite function. N theta differentiation is n. So r power n into cos n theta. Clear? Right. So n into r power n into cos n theta. Now we need to verify Cauchy-Riemann conditions. We found all the partial derivatives with respect to r, with respect to theta. So we need to find the Cauchy-Riemann conditions. We need to check the Cauchy-Riemann conditions. Now what are Cauchy-Riemann conditions for polar coordinates? Here it is not Cartesian coordinates. Here it is polar coordinates. What are the Cauchy-Riemann conditions for polar coordinates? So what we have discussed, right, clearly. So with respect to u, with respect to r. So dou u by dou r should be equal to 1 by r into dou v by dou theta. Dou v by dou theta. And with respect to v, dou v by dou r, here with respect to u with respect to r as well as v with respect to r. Okay, dou v by dou r equal to, so dou u by dou theta. Dou u by dou theta with a negative sign and a multiple of r. Okay, u with respect to r should be equal to v with respect to theta as a multiple of 1 by r. V with respect to r should be equal to u with respect to theta with a multiple of minus 1 by r. You should remember like this. Okay. So these conditions should satisfy here. Now I am taking the RHS part and prove the LHS. It is equal to LHS or not, we will check it out. Okay. Here I am taking first condition 1 by r into dou v by dou theta for our convenience. 1 by r into dou v by dou theta. Okay. 1 by r into what is our dou v by dou theta? We got n into r power n into cos n theta. So 1 by r into r power n. So if you take this r to the numerator, r power minus 1, r power n by r, already we know it, r power n minus 1 into cos n theta. Okay, n into r power n minus 1 into cos n theta. So 1 by r into dou v by dou theta is equal to n into r power n minus 1 into cos n theta. So where it is n into r power n minus 1 into cos n theta, it is clearly equal to ur. That means dou u by dou r. Dou u by dou r. It is clearly equal to dou u by dou r. That means first condition satisfied. First condition satisfied. Now I am taking the second condition is also taken by RHS part. So 1 by r into dou u by dou theta. Dou u by dou theta. So 1 by r into dou u by dou theta is minus n into r power n into sin n theta. Sin n theta. Okay, clear? So 1 by r into minus n into r power n into sin n theta. So if we take this r to the numerator, it is minus n into r power n into r power n by r is r power n minus 1 into sin n theta. So where it is n into r power n into r power n minus 1 into sin n theta. N into r power n minus 1 into sin n theta is nothing but Vr. So this is equal to minus Vr. Okay, if you take this minus to the LHS side, minus 1 by r into dou u by dou theta equal to Vr. That means clearly the two conditions are satisfied. Okay, Cauchy-Riemann conditions are satisfied. CR conditions satisfied. Therefore, f of z is equal z power n is analytic everywhere. So this is analytic everywhere because for any point it is not equal to infinity. Okay, clear? So if it is analytic, we need to find the derivative. We can find derivative directly by using the differentiation formula. Okay, we are having f of z is equal z power n. So we are doing differentiation with respect to z on both sides. So d by dz of f of z, that is equal to d by dz of z power n. So it is like d by dx of x power n. So what is the d by dx of x power n? N into x to the power of n minus 1. Clear? So here n into z to the power of n minus 1. Okay? So it is the differentiation of f of z is equal to z power n. Clear? So the problems of this type, z power n, like this, we need to use the polar coordinates. So these are the polar coordinates. This problem has to be done by using polar coordinates only. Okay, so in polar coordinates, Cauchy-Riemann conditions are 1 by dou u by dou r is equal to 1 by r into dou v by dou theta, and Vr is equal to minus 1 by r into dou u by dou theta. We need to check these conditions. Clear? So this is about checking analyticity of the given function. Clear? Okay, so in the further videos we will discuss some more problems of this analyticity, finding the unknown value if the function is analytic function. Okay, right? So if you like my videos, please share, subscribe to my channel. Please like, share and subscribe to my channel, and share to needy students. Thank you all. Signing off, Sridhar.